Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to revisit vast data and see what they've been doing the last 6 months. Randy Hayes, it has been 6 months since you've been on the show. You're now a VP. Holy cow. Oh, I'm bowing to you, Randy. You're doing a great job. VP of sales for public sector at Vast, right?
Thank you. Yeah, it's just a title. I'm still out here in the field trying to help customers solve some problems. So I think I'll never put my bag down. There's so many guys that are like spreadsheet jockeys and, from a VP perspective. And so that's definitely not me. So we're excited. We're growing a team. I've hired a bunch of folks and we have some more headcount. So the company's doing really well. We've grown quite a bit. Just in the last 6 months, we've sold about 70 petabytes of flash to the federal government. So we
love you guys. That's awesome.
We've been running hard. So yeah. And, so we got that going on. Let's see what else has happened in 6 months. I grew this sweet mullet, for the quarantine. So that's been going pretty well. It's quarantine in the back and Zoom in the front. So
yeah, there you go.
So we've had some fun with it.
We've talked about a couple of your new use cases that you found with your product, and I'm actually really excited about some of these use cases because you guys are kind of making some big moves in the storage arena, capturing some really big RFPs and some new use cases that we didn't talk about last time.
Yeah, it's been interesting when you brand the system as universal storage and you have this all flash storage system that you sell at the cost of hard drives. It allows you to go after a lot of different workloads in the data center, and so what we found to be really interesting is, just general file sharing. Sure, like that's great. We do that all day long, right? But, that's kind of boring, right? Like we like the fun applications that we're going after, right? And so we've been very successful around next-gen sequencing and confocal microscopy, a lot of AI workloads against, the image data that are being, brought in from all these different, whether they're sequencers or, microscopes. It's been pretty neat on that end. We've been doing some wind tunnel stuff, which is really cool when you start thinking about all the different, applications to what wind tunnel workloads can do. So all the simulations off of that. We've done some interesting stuff with SAR data, or synthetic aperture radar. That's just a really, really cool technology, when you start looking at, what the capabilities are and really the amount of data that those sensors create and then the processing needs that they have, right? And so we've done some cool stuff with that.
So where would you say your sweet spot? Because all those sound like big data. They all sound like large amounts of data, low latency. Is that your sweet spot? Is that where you guys really are chasing?
I think so. I think where, people struggle with what I like to classify the random read. And, the only way you can really solve the random read problem is putting all of your data on flash, right? There's a lot of like tiering methodologies and things like that. And, they could use some prefetch algorithms and things like that. But you really can't solve the true random read problem unless all of your data is on flash. And the only way up until, now, to do that was pay a lot of money. And so now that, Vast has come out with this platform where we've really equalized the price, flash to hard drive, it gives us the ability to actually put all of your data on flash.
Well, and you guys use Intel's Optane drives, they're the NVMe drives in a really clever way, because one of the cool things about Optane is the read-write parity. So you're not hampered, because everyone knows in storage, right? Writes take so much longer than reads. But that's not the case with Optane. So by front-ending your QLC drives on the back end, it appears very like your read-write is really close to each other.
Yeah, exactly. And so it's an interesting paradigm because there's so many benefits that we get out of Optane, right? So we've gotten rid of DRAM, right? Completely out of the right path. And so if you talk to anybody that actually builds like storage systems from the ground up, and you ask them like, hey, when you have an outage or when you have data loss, it's always a cache coherency issue or it's destaging data out of DRAM. And the fact that Optane's persistent and we have a transactionally consistent file system, that problem just goes away. And we don't have to have these really complex, destaging out of DRAM or cache coherency algorithms that you have to build into your software. It allows you to iterate on the file system a lot faster. So we've been able to add a tremendous amount of feature functionality into the platform in a really short amount of time because we don't have to worry about that cache coherency issue.
Well, shouldn't that also, that decreases your total cost for the user, right? Because I don't have to buy these big, huge, beefy machines with lots of memory just to do file storage. Where before I kind of did. If you want more speed, add more RAM into those systems so I can cache more. You've gotten rid of that tier.
You're 100% right. And, I think that's, you think flash is expensive on the storage side, flash on the server is way more expensive, right? And so, a lot of those problems go away when you have a millisecond of latency to all of your data.
So if I do have low latency, high volume, you guys are it.
Yeah.
I should give you a call.
We've solved a lot of problems across the federal government. We've solved a lot of people have challenges with, having to do this forklift migration every 5 years, right? Sometimes less. And it's always, it always cracks me up. Like if you're buying hard drives, you're never going to get more than a 5-year support contract from those folks because those things start deterministically failing at a very high rate after 3 years. And it's always magic. That year 6 support contract is the exact same price as a brand new system, right? And
of course. Yeah.
And so we're really doing away with that, right? So we provide a 10-year support contract if you want upfront. And so you can amortize this scale out storage system like a tape library across a decade. And so it gives you a lot of flexibility when you start looking at how you price things, how you, deploy storage at scale when you have the flexibility to keep something in the data center for 10 years. And we candidly, we look at it as in 10 years, a petabyte in 2U is going to be a bad use of rack space, right? Like who says that, right?
Yeah, so that brings up another interesting point. Scalability after. So let's say I buy a 3 petabyte system from you guys today. 2 years, I'm starting to bump up against the top end of my 3 petabytes. I can just add more, right? And it may be even more dense, the new boxes that I buy, right? Your D boxes, right? Your data boxes.
Yeah, D boxes, that's right.
Right, so I can just keep adding more of these boxes and my performance doesn't go down and they're completely compatible, right? So this gives me a way of almost wiping out the glacial storage, cold storage. I can just have one big storage array. Is it costs? I mean, does it make sense to do that? Because you had some customers that have done this, right?
Yeah, absolutely. And so we built this asymmetric architecture, and it allows us to have multiple different generations of both flash, right? So when we first came out, 3 years ago, we were shipping laptop flash in these devices, right? Like we're looking for the lowest cost flash we can get our hands on, right? And then, now we've switched to QLC flash from Intel. And, right now those are 15 terabyte drives, in a year or so, they'll be 30 terabyte. And then there's PLC and, all these other architectures. We can intermingle all of that flash all in a single global namespace. And so we allow you just to continue to grow your capacity with whatever we're selling at that current time. And so it gives a ton of flexibility because remember, we decoupled, right, disaggregated the state from the logic of the file system. And so those protocol servers that we sell are one part protocol server and one part global flash translation layer. So we don't even care the type of flash, that's underneath, right? We're doing TLC M.2s. Now we're doing QLC 15 terabytes. As the new generations continue to come, we can just add that all into the same system. And so it's been pretty powerful for our customers just to grow with what we have on the truck.
That's pretty impressive. So I can grow my storage capability. How big? What's the biggest you guys think you can theoretically get to?
There's I'll give you that. There's no theoretical limit, right? There's a testing limitation, right? But we've tested up to 100 petabytes. So
that's impressive.
And hey, anybody that's listen to the podcast, I challenge you to make us build one bigger, right? We're just trying to keep
just come and pay. Yeah, just come and pay us, right?
Yeah, exactly. I mean,
maybe you guys could have the first exabyte file system.
Yeah, for sure. I mean, that's the size and scope of the system. I mean, if you think about, our building blocks are 675 terabytes a clip. And so as we, get more and more flash, they're going to get bigger. They can get smaller. It really doesn't matter on our end.
So that's the next thing I have. I can grow capacity very large. What about access and what about speed? You guys talk about linear speed improvement, right?
Yep.
I just add more C boxes, right? And client boxes, right. Is that what C is? Client?
Yeah, C box, that's right, yeah. And so the nice thing about growing all of your capacity with flash is that performance basically comes for free, right? But you have to expose that flash with CPU. And so the fact that we can grow the capacity to whatever number you need in all flash, and then we allow you to pick how much performance you want to get out of that system. And so the C boxes are completely stateless so that you can grow them on the fly. You can shrink them on the fly. They can all die except for one, and you still have full access to every single piece of media on the back end. And so, that's one of the things we guarantee uptime. Like, what storage company guarantees uptime? Like, everybody expects it, right? But nobody actually guarantees it. And so not only...
So can I put a policy in the data side to say how many copies I have running? Does that make sense? I mean, because what if I lost a third of my boxes? Am I completely hosed of the D boxes, of the data boxes? I mean, because I can't have my data on nothing. It can't just be, out there floating around doing nothing. It's got to be sitting somewhere.
So each one of the D boxes are no single point of failure. So those, we just don't lose boxes, but we also have the ability to do RAID across the D boxes. So if you were to lose D boxes at scale, the system can auto balance across that.
So can I choose the different RAID levels that I want?
Not today.
Okay.
So we have some, because of the stripe widths that we do, we like to try and guide customers around how many D boxes and, that sort of stuff as far as what the failure domains look like. Because remember, we're doing 146 plus 4 stripe, right? So it's like a preposterous stripe width to begin with.
Yeah.
And the reason that we could do that is Optane, right? So we could coalesce all that data in Optane with these huge write buffers. And then also because all of the C boxes participate in the stripe, we can write to 150 flash devices at exactly the same time. And
Very cool. So if I want to improve my performance, I buy more C boxes independent of the D boxes.
That's correct. And we have a lot of customers that are, they've kind of like, we just don't have the need for any more performance. We just need more capacity. And so, we see clusters that have like 11 C boxes and 37 D boxes, or, 4 C boxes and 20 D boxes. It really just depends on what the performance requirements are from a customer.
So what could I normally get out of a typical C box as far as performance goes?
So so you look at it from a bandwidth perspective, right? So if you have one C box and one D box, you're looking at about 40 gigabytes a second of bandwidth. That's like just the base model, right? And then every time you add a D box, that adds another 40 gigabytes of bandwidth. One C box doesn't saturate all the IOPS. So if you add another C box, you can get, 350,000 IOPS out of a box. And then as you add more C boxes, you can add more IOPS as well. Because again, Flash is CPU bound. So the more CPUs you throw at it, the more threads we can throw. And it really allows you to scale, kind of in a bunch of different vectors if you think of it from that perspective.
Very cool. All right. So we've talked about this before. Great refresh on it. What's new? What's new from you guys? What, besides supporting Intel's latest processor, I got to go throw that in, right? Ice Lake is supported. Yay. All right. So we got that out of the way. What else is new with VAST?
New Optane too, right? So
that's right. New Optane Barlow Pass, right?
Supporting new Optane again, which helps us across the board, right? It speeds up metadata, it speeds up write performance, it speeds up read performance, it speeds everything up. And so, plug for next gen Optane.
There you go. So we got the plug in. Let's talk about brass tacks. What's new coming from you guys?
Yeah, so recently we came out with a program called Gemini, and so the general thesis around Gemini was, we have customers that have this like, hey, we need all this performance, but we don't need that much capacity, right? And so back in the day, if you're doing HPC or AI or anything like that, to figure out your performance, you have to count spindles and see like, all right, this is how many hard drives we need to get this bandwidth, right? And so you had to buy all of those hard drives up front, and you had all this capacity that maybe you didn't actually need. And so with this Gemini architecture, it gives us the ability to present the hardware directly to the customer. So the customer can buy our exact hardware configurations directly from our contract manufacturer. So it lowers the upfront cost from a hardware perspective. And then we give you the ability to license this in either 100 terabyte increments, or you can license a full D box. And so what this allows you to do is build this really big, really fast system, but only license a very small portion of this, for, how long you need it. Like, we have customers that are, 40, 50 petabytes. Well, guess what? It takes a long time to write 50 petabytes in. So why should you be paying for 50 petabytes day one when it's going to take you a couple of months or a year or longer, to grow that capacity level? So there's a big cost savings on that. We also started to see a lot of customers start looking at OpEx models, right? Whether it's because of the cloud or the way, their programs are being run. This also gives customers a much lower upfront cost, and you can then pay for the system from an OpEx perspective. And so just to give you kind of a little bit of a teaser, that first year of storage, we did a quote recently for a big government customer, is about 30 petabytes or so. And we looked at the pricing and we're like, whoa. You get a 30 petabyte all flash system that does about 1.5 terabytes of bandwidth, and the cost is less than S3 infrequently accessed from Amazon.
Oh, that's incredible.
And that's just year one. And then for the out years, it's actually less than Glacier. If you look at it on a per gig per month basis, the way Amazon charges, and this can go for Azure or Google or anybody else. I'm not picking on Amazon, but when you look at that, you now have this all flash file system that costs less than Glacier. And so for those people that want to do the OpEx model, this gives us the flexibility to do that as well.
So you guys, you're basically offering storage as a service, kind of, right? On-prem. Right. And I love the OpEx model. A lot of people are moving to that right now. And you still have the flexibility to go back to a CapEx model when the business trade winds change and everyone's like going, what happened to all of our CapEx, right?
Yep, exactly. And so it gives you the ability to do CapEx. If you got a big upfront chunk of money, we can do that, or we can do OpEx. And so it gives us a little bit more flexibility on supporting customers. Also having a kind of a smaller footprint to get in, because candidly a petabyte is about what you get out of a single D box with our compression ratios. Sometimes that's a little bit of a big bite for people. And
Yeah.
so the fact that we can start now at 100 terabytes gives us a little bit more that we can support from a customer perspective across the board. So yeah, it's.
So I love the new business model. I think it's clever, and you're right. It will help some people get into a better storage solution that will scale over time without forking out millions of dollars.
Yeah, and the one thing that we really wanted to, kind of make sure that everybody understood was we're still presenting an appliance, right? There's a lot of companies that are doing like storage as a service or software as a service, and you can run it on like whatever you want, right? And so that's fine, but that's a support nightmare, right? When you think about all the different iterations and variations of both hardware and firmware, and what drives are you supporting, and what servers are you supporting, what interconnects, NICs, like all of those things, all the drivers of all those things, it adds a crazy amount of complexity. And so we're still shipping the same boxes, the same servers. It's still a turnkey appliance. It's just more of a business model to allow our customers to be a little bit more flexible in how they consume storage. And so I think we were joking before, it's like a flea flicker, right? It's like, hey, we're going to run the ball. Here's your, appliance. And then you pull the ball back and you go for the home run for those really big, storage architectures that are out there in the federal government. And so
I like that you guys are giving customers a choice and something a little bit different. So where do you see the next set of use cases that you guys could really chase after with this storage? Are there any new ones out there? Are there things that you would like to get more involved in, or where you see this could be taken?
Yeah, I think there's a couple of places that I think are going to be really interesting. We were just on, actually this morning I was on with a customer, and they were, really complaining about digital pathology. And so, the amount of data that's being produced from a digital pathology perspective is just, it's astronomical. And they really struggle with performance because it's so much data. They have to do this like tiering of data and put it on cheap, slow storage. And then it hurts the performance when the researchers are trying to access this data. And so I see that, starting to become a lot more prevalent. I also see a lot of precision medicine where, doctors are going to be prescribing certain things because of your, genetic makeup. So, I think, whether it's FDA or CDC, certainly places like NIH are all thinking about this problem. You look at the VA, you look at DHA, these are all places that are trying to help solve these problems. And so I see those as continuing to be a really good place. I also look at, we just won a deal for some AI against packet capture. And I think with the amount of cyber, you can call it espionage, call it attacks, call it whatever you would like, there's problems, right? And we have a lot of adversaries that are trying to come after us. And I think running AI against, packet capture, whether it's like Splunk or Elastic or some other medium of, ingesting these log data, it becomes really interesting because, at one point it was a very point in time problem, like, hey, what's going on right here? But now you have to look back over years because there could be nation states that are probing, right? They're probing.
Or like we saw with SolarWinds, they probed 2 years ago.
Right, exactly.
And they sat and waited for 2 years. That's crazy.
Yeah, and so
I can see that.
So having access to 2, 3, 4 years of log data now all of a sudden becomes really important when you're training models, to basically predict where, some of these things are going to happen. And so I see that being a really big thing, both for the federal government as well as, industry, because the SolarWinds attack was, it was, basically the back door around the SolarWinds, right? And so I don't think a lot of people saw that coming. And
No.
How do you infiltrate the federal government? Like basically through a back door, right? And so it was pretty interesting. So I think we'll probably see more of things like that. I know Facebook just, there's all kinds of news right now about, Facebook getting, hacked and, that sort of stuff. So it'll be interesting, but I think cyber is going to be a really big jump off for a lot of work that we're going to do.
Yeah, I agree. And I was thinking also, I personally have a lot of storage sitting up in the cloud doing nothing.
Yeah, I think
What if, and this is Darren's crazy thought, so tell me if I'm off kilter, because you know me, I get off kilter. What if I had all of my storage in a vast data system, so it's fast, right?
Yep.
And cheap enough where it's comparable to, cold storage and glacial, costs. But what if I actually ran analytics on all that data that's just sitting out there doing nothing, not providing any value? Because before I couldn't run analytics on it because it was too costly to move around. But now maybe it's not that costly. Maybe I can actually start finding nuggets of information in these data sets that are 5-10 years old.
Yep.
That I still have because I'm scared to get rid of data, but I put it in a place where I can't do anything with it.
Yep. No, it's interesting. We're starting to see a really big uptick of both colo providers providing services like this, where you're putting your storage in a colo that's adjacent to a cloud vendor's data center, so that you have really low latency. And then, oh, by the way, you also throw in an all-flash storage system that's got a millisecond of latency that minimizes that tax to bring it up into the cloud as well. And so I think, that's one of the interesting pieces is we actually have a good chunk of customers that do almost all of their compute in the cloud and put almost none of their storage in the cloud because they don't want to pay that tax.
It's expensive
every single month, right? So it's definitely an interesting use case. The fact that we do cross protocol with NFS and S3, you could have on-prem resources accessing that data via NFS. You could have cloud resources pulling that data, either NFS or S3. And so it gives you a lot of flexibility to do kind of a hybrid or, multi, cloud hybrid approach where you have a centralized on-prem storage system that then can be accessed via multiple different cloud providers.
Very cool. So you don't have to pay, because ingest into clouds is free.
Yep.
Storage is not, and egress is expensive. So I kind of like, this is a cool model, right? I can use all the compute assets in the cloud, and that's all ingress, right? I don't have to ship anything back to my storage, just the results, which are a lot smaller. That's actually pretty slick.
I couldn't have said it any better, right? I mean, it's a lot, it's kind of the inverse of like high performance computing, right? You start with a small bit of data and then you have like a tremendous amount of data, right? AI is the complete inverse of that, right? Where you have lots
large
of data
to small.
And then, but then the data that you're looking for, right? The results is typically a very small, like it could be like a phone number, right? Or an IP address, or like it literally could be like just a couple, bytes of data. And hey, that's pretty inexpensive to pull out, right? So
that's an interesting mod. I'm going to have to draw that up. You know me, I'll have to try it at home and see what happens.
Yeah. So. There's a lot of good companies that are doing some interesting things as far as that multi-cloud, inbound, outbound, type of architecture. So I think those roads are pretty well paved at this point, and so. It's really just sitting down, talking to your cloud providers to understand what their options are for, ingesting data from on-prem.
Very cool. And you guys have a great architecture to store it and actually egress it into the ingress of the cloud very quickly, which is what we like to see. Yep. Well, great, Randy. As always, it's a pleasure talking to you. This has been fun. I can't wait to talk to you again in 6 months, see how long the mullet is getting. Maybe you'll come with braids next time, hanging down. I don't know.
No, exactly. Maybe just a mustache. I feel like the mullet and mustache, like just go full all 80s and just call it a day. But so no, I appreciate it. And 6 months would be great. That would be right at the end of the federal fiscal year, just right after the end of the federal fiscal year, and we'll give you a great update on all the cool stuff that we've done.
Sounds great. Hey, thanks again, Randy.
Yeah, absolutely. Thanks. Take care. Thanks, Darren.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.